So let's go for some more problem. So here we have our potential. Vx is equal to infinity if x is less than 0 and is equal to half m omega square x square if x is greater than 0. So suppose this type of potential is there and we just want to calculate the energy from the WKB approximation. So obviously this is a semi-parabolic potential and this one boundary is rigid. So if this boundary is rigid, then obviously we have to go from x1 to x2. And what will be the condition? The quantization condition is all about px dx is equal to n minus 1 by 4 pi h cut. And here we will go for 1, 2, 3 and so on. In some book, it is also given n plus 3 by 4, then n will run from 0, 1, 2, 3 and so on. So it will depend that which boundary condition or which quantization rule you are using. So obviously, suppose I am talking about this particular value of energy, and this energy can be written as E is equal to px square upon 2m plus, I can write from here, E is equal to px square upon 2m plus half m omega square x square. And again, you can see, you have to find this particular value, and this particular value is your x2. x1 is 100% 0. There is not any problem. How we will get x2? We will get momentum px is equal to 0. And once we will get momentum px is equal to 0, we will get x is equal to root under 2e upon m omega square. So let's try to go for this integration. And from here, we can also get value of px. So obviously, we will go from 0 to root under 2e upon m omega square and root under 1, sorry, and this value is 2m e minus half m omega square x square dx. And in the last class, we have also discussed how we will solve it. So yes, you will just make it dimensionless, take 2me common, and then you have e2e upon m omega square. You have 1 minus m omega square upon 2e x square dx is there. And again, you can put x root under m omega square upon 2e must be equal to t. And when your x is equal to 0, t is equal to 0, and x is equal to 2e upon m omega square, your t is equal to 1. So you can, and we can also find the value of dx. That value is equal to 2e upon m omega square dt. And we have value 0 to 1 and root under 1 minus t square dt. You have exactly same thing we are doing here. 2e upon m omega square. Okay. And that value must be equal to what? N minus 1 by 4 pi h cut. So how we will solve this integration? So we have root under 2me into root under 2e upon m omega square, and we can solve this integration. And this integration we have solved already. That value is what? Pi by 4. Last class में हमने solve किया था. कैसे solve किया था? We will put t is equal to sin theta and we will get this particular thing. So that value is equal to n minus 1 by 4 pi h cut. So what is this value? This m and m will cancel. So 4 and 4 will cancel. What we will get? This pi will be there. So pi and pi will cancel. So E is equal to what? N minus, sorry, 2 will be there, na? So this value is equal to E pi E upon 2 omega, and that value is equal to n minus 1 by 4 pi h cut. This and this will cancel. So E is equal to n minus 1 by 4 2 times h cut omega. Yes. And now you can see, if I will put n is equal to 1, what will be answer? If I will put n is equal to 1, so what is value of energy?
3 by 2.
3 by 2 h cut omega. That is exactly same value we have calculated earlier discussion into semi-parabolic potential. Isn't it? Okay. So this is one of the very nice problem. Let's go for another one. Everyone is comfortable?
Yes, sir.
Okay. And please इसके अंदर जो भी प्रॉब्लम आएगी they are very straightforward, है ना? So you have to just do your integration very carefully. Okay. So let's try to solve the problem when particle is fall under the gravity with the WKB approximation. So let's try to solve it. So what will be your potential? So Vz is equal to mgz when z is greater than 0, and that value is infinity when z is greater than 0 and z is less than 0. Why I am saying this is infinity? At the surface of Earth, I am assuming my z is equal to 0. So your ball will cannot go beyond the surface of Earth. So we can assume that surface of Earth is a rigid boundary, and you have potential mgz. So obviously this is my potential. So this region has infinite, and this is just a straight line. mgz is there. Okay. So particle in a gravitational field. Particle in gravitational field. So we can solve this type of problem. Okay. So obviously, again, we have to write energy, and this energy is equal to, here we have to go for pz square upon 2m plus mgz. So you are throwing particle just vertically upward. Okay. And this will be my energy. Let us assume this is my Vz versus Z. And this will be my energy. This is my energy. Sorry. This is my axis. And this will be my energy. This is my Z axis. Okay. And this is a straight line. Just this is a straight line. So obviously the first point is 0. The second point is what? Z1. What is value of Z1? Pz is equal to 0. So Z is equal to what? E upon mg. So this value is equal to E upon mg. And we have to go from Z1 to Z2, Pz, dz. And what will be boundary condition? I can take n minus 1 by 4 pi h cut. This is our boundary condition because one end is rigid in this case. So if this end is rigid, then you have to take this one as boundary condition. And obviously we have to go from 0 to E upon mg, and where we have to write the value of pz here. So that value is equal to root under 2m E minus mgz dz. And this value must be equal to n minus 1 by 4 pi h cut. So what do you have to do? First we have to take 2me common. And you have 0 to E upon mg. And we have 1 minus mg upon E into z root under dz, isn't it? And what should be t? यहाँ t क्या होना चाहिए आपका?
mgz by e.
mg z by e. So here dz is equal to dt e upon mg. So this is very routine type, and this is root under 2me, don't worry. So this is 2me into e upon mg, and we can go from 1 minus t dt, and you will grow from 0 to 1. And how you will solve this integration? कैसे solve करोगे? How you will solve this integration? बताओ.
Sir, t equal to sin square theta put कर.
अरे इतना क्यों complicated? This is linear. Sin square theta put करो तो और भी ज्यादा complicated हो जाएगा ना? So this is linear. You can just put 1 minus t is equal to y, isn't it? So dt is equal to minus dy, and t is equal to 0, y is equal to 1, and t is equal to 1, y is equal to 0. And minus sign is there. So again you will go from 0 to 1. So you have 2me into e upon mg. You will go from 0 to 1 root y dy. And what is this integration? ये linear है ना? अंदर में linear है तो सारे चीज को आप y put कर सकते हो. Are you getting my point?
Yes, sir.
है ना? So what will be this integration? 2 by 3, isn't it? And that value is equal to what? N minus 1 by 4 pi h cat, where n is equal to 1, 2, 3. And from there, you can easily calculate the energy. So now how easily we can use this particular formulation of semi-classical theory to find different type of energy, isn't it? So you have 2m and root under 2m, or m to m is cancelled. So you have basically root under 2 by m 1 upon g e to the power 3 by 2 is equal to n minus n minus 1 by 4 pi h cat. And from here you can see E is equal to G, and you have m upon 2 root under n minus 1 by 4 pi h cat to the power 2 by 3, isn't it? So here you have this particular thing. है ना?
सर ये इंटीग्रेशन का वो पावर नीचे नहीं आएगी 2/3?
इसलिए तो 3 by 2 कर दिया. अच्छा सॉरी 3 by 2 लिखा नहीं. ओके ओके 3 by 2. सो यहाँ पर क्या होगा 2 by 3, है ना? 3 by 2. ओके, so 2 by 3 will also multiply with this. Good, thank you. है ना, ये मिस हो गया था. ओके
सर 2/3
इसको इधर ले जाएंगे तो 2 by 3 होगा ना. सॉरी यहाँ पर क्या होगा, इंटीग्रेट करेंगे. So when we will integrate it, what you will get? Root under 2me e upon mg, and this value is what? 2 by 3. So this value is what? 2 by 3. And here we will get 3 by 2. Good. ठीक है ना? Are you getting this one? Hello. Is that calculation is correct? हेलो,
Yes, sir.
कैलकुलेशन सही है?
Yes, sir.
है ना?
Yes, sir.
जस्ट यहाँ पर आप इंटीग्रेट करोगे, देन दिस विल बी 2/3 एंड दैट वैल्यू इज इक्वल टू n-1/4 pi h cut. Okay, and then from here we can get this one. Okay, so अब एग्जाम में आपको यह ध्यान देना होगा कि इसे आप कितना कॉम्पैक्ट वे में लिख सकते हो और एग्जामिनर किस फॉर्म में देगा, दैट विल डिपेंड्स ऑन देम. So in general I am interested into n, so I can say here that En is proportional to n-1/4 to the power 2/3. This is more important thing. Okay, this is more important thing. Chalo, let's try to go for one more problem. Clear है ये everyone?
Yes, sir.
Okay. So let's try to go for one more problem where Vx is equal to lambda mod x. Suppose this is your problem. So Vx is equal to lambda mod x, and it is given that E1 is the energy when lambda is equal to lambda. E1 is the ground state energy where lambda is equal to lambda, and E2 is the ground state energy when lambda is equal to 2 lambda. Okay, E2 is the ground state energy when lambda is equal to 2 lambda. So you have to find value of E2 by E1. So you have to find value of E2 by E1. So here you have to work with the lambda actually, isn't it? So which type of problem there? This is your potential, है ना?
Smooth
This
down.
is your potential, smooth potential, isn't it? And this is your Vx versus x. So first we have to find the how my energy is proportional to lambda. So there is not any need to do all the calculation, isn't it? Let me just do this one. So what is your energy? Your energy is equal to px square upon 2m plus lambda mod x. So we have to just go for this two value. This is my x1 and this is my x2. So what will be my reason? x1 to x2 is equal to px dx is equal to n. What is this value? N minus half pi h cut. Isn't it? Are you getting my point?
N plus half. Half pi h.
n माइनस हाफ भी लिख सकते हो, n प्लस हाफ भी लिख सकते हो. अगर n माइनस हाफ लिखेंगे तो n इज इक्वल टू 1 2 3. ओके, n प्लस हाफ लिखेंगे तो n इज इक्वल टू 0 1 2 3. कल हमने डिस्कस किया था. ओके, क्लियर है ये?
Okay, sir.
नाउ व्हाट इज वैल्यू ऑफ x1? What is value of x1? Huh?
E by lambda.
Minus e by lambda.
Yes,
Sorry.
minus
Yes, sir.
E by lambda.
है ना? So you have to go from minus e upon lambda to plus e upon lambda. So this will be your minus e upon lambda, and this will be plus e upon lambda. You can just put px is equal to 0. So e is equal to lambda mod x. So you it will be positive in this side, negative into this side. So you have to this one. And when you will go for this integration, you have 2m e minus lambda mod x dx is equal to n minus half pi h cut. Okay. Now, and for the ground state, n is equal to 1. So minimum value is n is equal to 1 you can put, because these two are given for the ground state. For ground state. Now, look at, there is not any need to calculate this integration. So this integration is even integration or odd integration?
Even.
Even integration. So you can just go for 2 times 0 to e upon lambda 2m e minus lambda x. Hence we are going from 0 to lambda. I can go from mod x is equal to x. Everyone is comfortable?
Yes.
That value is pi h cut. So now when we will make it dimensionless, and we will, then what you will get? You will get 2 into root under 2me. The same process we are going to do in the, as we have done into last class, sorry, last problem. And we have e upon lambda integration 0 to 1. We have 1 minus t dt. Same process. And that value is equal to what? N minus half pi h cut. And for the ground state, n is equal to 1 is there. So from here, I can say E is proportional to lambda to the power 2 by 3. Yes या no? Just look at here. क्योंकि हमें E और lambda के बीच में बात करना है. यहां पर आप पैरामीटर के साथ ओपन करो. And this integration is exactly same we have done into the last problem. So why I am writing it directly. ठीक है ना?
Yes.
And ये इंटीग्रेशन करने की जरूरत भी नहीं है, because this is dimensionless quantity, then this will be some fraction, don't worry. And e to the power 3 by 2 is proportional to lambda, isn't it? When lambda will go into this side. So what will happen? So if we want to calculate this one, then you have e2 upon e1 is equal to 2 lambda to the power 2 by 3 by lambda to the power 2 by 3. So what is e2 by e1? So you have e2 by e1 is equal to 2 to the power 2 by 3. So this was problem asked into, I think, last year. Yes? Are people comfortable? तो आपको ये हमेशा दिमाग में रखना है कि कहां पर कंप्लीट कैलकुलेशन करनी है और कहां पर आपको जस्ट प्रोपोर्शनलिटी में काम कर लेना है. Okay? Suppose someone will ask you that energy is proportional to only n. आप अगर चारों ऑप्शन देखोगे उसके कांस्टेंट सबके अलग अलग हैं और n का पावर डिफरेंट है, तो आपको कंप्लीट इंटीग्रेशन करने की जरूरत नहीं है. You have to just work on into the energy. So you have just keep energy and the parameter outside the integration, and this integration will be 100% some fraction value. So don't worry. This integration is 2 by 3, isn't it? So that value is always a fraction. So, and we have discussed this thing in our classical mechanics course also, this type of discussion in a very detailed manner, when we have just calculated the area under the phase curve and all this thing. But here, you can see how we can use the parameter to understand the system. So you have to be very much careful when you are using the parameters. Okay. So let's go for the next level of problem, that will be that calculation of tunneling probability. So from the WKB approximation, we can also calculate the tunneling probability of in the classical forbidden region. And we all know that a particle will tunnel down into the classical forbidden region when we are going to apply the quantum mechanical approach. So let's try to go for this. यहाँ तक clear है ना? Everyone? Chalo. So what will happen when you have, suppose this type of potential, or then your particle will come and it will tunnel down and something like this. And this region is classical forbidden region. Obviously, this potential is V naught and E is less than V naught. So whenever you have energy which will be less than your potential, so my energy is less than my potential. Okay, you can say this is your potential and you can tunnel down. So the tunneling probability is from the WKB approximation is more or less e to the power -2 gamma. This is your tunneling probability. And you have to calculate the value of gamma. So what is your value of gamma? So your value of gamma is equal to 1 upon h cut integration. Obviously, between the point where this is going to tunnel down. So that is, this one is x1, this one is x2. And you have mod px dx. So you have to careful about your energy and potential. So you can easily calculate what will be your tunneling probability. So let's try to use this formula and we can easily calculate what is my tunneling probability in terms of e to the power minus gamma, where gamma is this particular thing. Let's go for this one. So Vx is equal to V naught, where x is between 0 to a and 0 otherwise. 0 otherwise. So you have this sort of potential, exactly same potential. And if my energy is less than V naught and greater than 0, then find the tunneling probability. So what will be tunneling probability? So I am talking about this much of energy. So my particle will tunnel down between this one. So this is 0 and this is a. So most important thing is how we are going to calculate gamma. So gamma is equal to 1 upon h cut. And when we will go for x1 to x2, and hence my energy is less than potential, and we have to take the mod value of this. So this value is Vx minus E, isn't it? dx. Clear है ना? Then only you can have this one. और ये आप करते भी हो जब आप डिफरेंशियल इक्वेशन श्रोडिंगर वेव इक्वेशन की सॉल्व करते हो, then you are making the thing positive. Remember? d square psi upon dx square minus gamma square you are using deliberately, and that is the same gamma we are using here. Psi is equal to E psi. Remember? When
So,
you have solved this step potential and all this thing, याद है?
Yes, sir.
Yes,
है ना?
sir.
Okay. So let's try to go for this problem. So
हम
here,
डायरेक्ट ले रहे हैं ना?
sorry,
गामा के लिए जो फॉर्मूला है ये डायरेक्ट ले रहे हैं या कहीं से डिराइव हुआ है?
ये डिराइव हुआ है वो फॉर्मूला है जिस तरह से आपका,
हमें लर्न करना है?
सॉरी,
हमें लर्न करना पड़ेगा ये?
नहीं आप जस्ट इसको रिमेम्बर करो, ये तो बिल्कुल ही सिंपल है, ठीक है?
Okay,
so
sir.
that T is the tunneling probability, na?
Yes, T is the tunneling probability. T is the tunneling probability. Okay? और इस लर्न क्या करना, ये तो आपको पता है भाई, जब भी चीजें टनल होती है तो उसकी तो प्रॉपर्टी इसी ढंग से होती है, एक्सपोनेंशियली
Yes,
डिकेइंग, isn't it?
Yes, sir.
And
Yes.
any function which is just going to exponentially decaying, you can approximate with your exponential function with the negative sign. जैसे साई आपका कैसा आता था, याद है? साई x is equal to e to the power minus gamma x kind of thing. Remember?
Yes, sir.
And what will be mod psi square? E to the power minus 2 gamma x. ये एक पर्टिकुलर x की बात कर रहे हो आप यहां पर, isn't it?
Yes, sir.
लेकिन मैं अगर पूरे रेंज की बात करूंगा, then obviously we have to go for this integration, है ना? तो this will be, आप कहां से कहां जा रहे हो, टनल कितना देर कर रहे हो, तो that will dependent on this particular gamma, and this gamma is number. अभी तक हमने जो प्रॉब्लम किया था वहां पर ये गामा कांस्टेंट की तरह बिहेव कर रहा था. Why? Because we are using our potential as constant, such as in this problem. But अगर potential function of x होगा तो भी हमें एक पर्टिकुलर गामा की वैल्यू मिलेगी, and that will derive from this particular thing, and we can easily use this particular formulation ऑफ अ फ्री पार्टिकल। WKB की पूरी फॉर्मुलेशन ही फ्री पार्टिकल के साथ और कांस्टेंट पोटेंशियल को लेकर के है, बिकॉज हमारे पास जो अप्रोच है वो क्या है, दैट पोटेंशियल इज स्लो वेरिंग। व्हाट इज मीनिंग ऑफ स्लो वेरिंग? दे आर ऑलमोस्ट कांस्टेंट, वी आर चेंजिंग टू x plus dx। आर गेटिंग माय पॉइंट?
यस सर।
है ना? तो अगर आप कांस्टेंट रख रहे हो पोटेंशियल को x plus dx, तो आपका इन जनरल सॉल्यूशन कैसा है? इन जनरल सॉल्यूशन इन द क्लासिकल अलाउड रीजन e to the power I kx, and into the classical forbidden region e to the power minus gamma x, isn't it? और कल भी आपने देखा था हमारा जो अप्रोक्सीमेटेड सॉल्यूशन था, वो सॉल्यूशन क्या था? a रूट अंडर px e to the power plus minus I, and this integration is x1 to x2 px dx। रिमेंबर? ऐसा ही तो था। And when you are into the classical forbidden region, this plus minus I will change with what? Minus sign, and here you will go for what? Mod psi, isn't it? है ना? And we have to take mod of psi here. mod p here. आपको याद होगा जब हम लोगों ने स्टेप पोटेंशियल किया था, तो यहां पर क्या था सॉल्यूशन? e to the power I kx टाइप सॉल्यूशन, और यहां सॉल्यूशन क्या था? e to the power minus gamma x। Remember?
Minus. Yes.
So we are doing exactly same thing here also, but यहां पर आपके पास ये px dx इंटीग्रेट करके आप अप्रोक्सीमेट वैल्यू ऑफ गामा निकाल सकते हो, जो इन जनरल कांस्टेंट पोटेंशियल के लिए कांस्टेंट है। और आपका एजम्पशन है, योर एजम्पशन इज दैट पोटेंशियल इज वेरी स्लो वेरिंग। स्लो वेरिंग मीन्स व्हाट? व्हेन यू आर चेंजिंग x to x plus dx, the potential Vx is almost constant. Are you getting my point? Almost constant. And you are just working into that particular region. So why we have dx here? Clear है ये? And why in the tunneling probability, why 2 factor is there? Because your wave function is something like this. आपका wave function अगर ऐसा है, suppose your wave function is psi x is equal to a by root under mod px and e to the power minus gamma x kind of thing, or minus gamma, or you can have something x1 x2 px dx। so mod लोगे तो यहां पर 2 तो अपने आप आ जाएगा ना, isn't it? जब भी आप प्रोबेबिलिटी की बात करोगे, then you have to go for what? mod psi square, and this value is approximately e to the power minus 2 gamma, and this is the exactly same thing you are getting here। ठीक है? so आपको याद करने की जरूरत नहीं है, logically we have derived each and everything। okay? चलो, so let's go for this particular potential। sorry, so here we have gamma is equal to 1 upon h cut, 0 to a you have 2m v naught minus e dx। so this is, and this is constant value, you can easily find gamma is equal to 1 upon h cut root under 2m v naught minus e into a। what is your tunneling probability? e to the power minus 2 gamma is equal to e to the power minus 2 upon h cut root under 2m v naught minus e a। that's it। क्लियर है ये? एवरीवन कंफर्टेबल? चलो, प्लीज रिस्पॉन्ड, कुछ पूछना है?
Yes, sir.
ओके
हाँ,
सर।
ओके. So let us go for one more problem. So Vx is equal to V naught minus lambda x. Okay. So this is V naught minus lambda x, where x is greater than 0 and 0 otherwise. So if E is less than V naught, find tunneling probability. Okay. So ये पोटेंशियल कैसा होगा? This type of potential, with say potential. So at x is equal to 0, you have V naught, and as you increase the value of x, the potential is linearly decreasing. So this is your Vx versus x, triangular shape potential. And we have E is between 0 to V naught. So somehow this is my E. So first we have to calculate the value of gamma, then you can easily calculate. So we have to calculate e to the power minus 2 gamma. So let's try to calculate gamma. What is gamma? 1 upon h cut x1 to x2. We have to go for mod px dx. And this value is equal to gamma 1 upon h cut. You will go from 0 to which point? This point. What is this point? This one is 0. So this is the region where the particle is going to tunnel down. These all are classical allowed region. This is your region where particle is going to tunnel down. What is this point? क्या होगा ये? Just tell me, what is this point? क्या है ये? Anyone? So this point is again turning point. अगर आप इस रीजन से अप्रोच करते हो तो क्या होगा? V naught lambda. So that value is V naught minus lambda x. And at this point, Px is equal to 0. So when your Px is equal to 0, so what is your x? बताइए. V naught minus E by lambda. This is your x. So this value is equal to what? V naught minus E by lambda. And what is your Px dx? So you have your Px, and that is mod value. So you have 2m V naught minus lambda x minus E dx. है ना? So we have to do this integration. Clear है ये? So when we will do this integration, I can put 2m, hence it is all are linear. X, this is linear of x. So I can put V naught minus lambda x minus E is equal to t. So you have minus 2m lambda dx is equal to dt. So your dx is equal to minus 1 upon 2m lambda dt. Now at x is equal to 0, t is equal to v naught minus e. है ना? मेरे कुछ तो बोलो. हेलो.
Yes, sir.
So at t is equal to 0, you have, sorry, x is equal to 0, t is equal to So x is equal to 0, t is equal to 2m v naught minus e, and x is equal to v naught minus e by lambda, then t is equal to 0. जरा put करो, e v naught minus e by lambda, lambda cancel, so everything is cancelled out, so that will be 0, and hence this is negative sign, so I can write this particular thing, this gamma is equal to 1 upon h cut 1 upon 2m lambda and 0 to 2m v naught minus e, and this value is equal to t to the power half dt. So this gamma is equal to 1 upon h cut 1 upon 2 by lambda, and this value is equal to what? 2 by 3, isn't it? Into 2m v naught minus e to the power 3 by 2. Clear है ये? Yes? So you can see. And 2m v naught minus e, something like this. So what will be your t? Your t is equal to e to the power minus 2 upon 2 h cut m lambda into 2 by 3, and you have 2m v naught minus e to the power 3 by 2. हो रहा है ये? जस्ट चेक इट, एंड इसके बाद आप जो चाहो उसको ऐसे लिख सकते हो. सो t इज इक्वल टू समथिंग e टू द पावर minus 2 upon m lambda h cut 2m v naught minus e to the power 3 by 2. लास्ट प्रॉब्लम में क्या था? पावर. टर्निंग प्रोबेबिलिटी कैसे था? v naught minus e का हाफ, isn't it? When you have constant potential, remember this one? इसमें क्या था? E is turning probability is proportional to some alpha, so that is some constant, and you have 2m v naught minus e to the power 1 by 2. And when your potential is linear, then this is something like 3 by 2. है ना? Everyone getting this one? This thing? Are people there?
Yes, sir.
ठीक है, हाँ ना कुछ तो बोलो.
सर लास्ट स्टेप थोड़ा सा इस साइड करके बता दीजिए, वो ना पता नहीं लग रहा.
कहाँ पर प्रॉब्लम है बताइए?
सर जो इस साइड आपने लिखा है ना, वो लास्ट स्टेप क्या सर?
ये वाला?
रिपीट. ये हाँ जी.
अरे भाई अभी
सर,
एक प्रॉब्लम किया था, ये प्रॉब्लम अभी किया ना? अरे
यस सर.
ये किया प्रॉब्लम अभी?
थोड़ा सा राइट साइड पे.
अरे लिख रहा हूं मैं, पूरा लिख रहा हूं, आप देखो तो. ये प्रॉब्लम किया अभी? इसमें आपकी टर्निंग प्रोबेबिलिटी क्या है? टर्निंग प्रोबेबिलिटी प्रोपोर्शनल टू e टू द पावर सम कांस्टेंट, है ना? लेट अस सम कांस्टेंट इज अल्फा, जो a वगैरह है, और अंदर क्या आ रहा है? और m को भी कांस्टेंट में ले लो तो क्या आ रहा था आपका? v नॉट माइनस e टू द पावर 1 by 2 आ रहा था. आर यू गेटिंग दिस थिंग?
यस सर.
अभी के टर्म में क्या आ रहा है? लेट अस सपोज करो इसको अल्फा 1 ले लेते हैं, ठीक है? अभी आप टर्निंग प्रोबेबिलिटी e टू द पावर माइनस अल्फा 2, ये बाकी सबको आप कांस्टेंट में पुट कर दो, कर सकते हो ना? और अभी क्या आ रहा है? v नॉट माइनस e टू द पावर 3 by 2.
यस सर.
समझ रहे हो? तो कहने का मतलब क्या है? कहने का मतलब यह है कि अगर आप नेचर ऑफ पोटेंशियल चेंज करते हो तो आपको टनल होने की प्रोबेबिलिटी भी क्या हो जाती है? चेंज हो जाती है फॉर द गिवन वैल्यू ऑफ एनर्जी। अब बहुत नेचुरल भी है, एंड अब ये प्रोपोर्शनलिटी मिल रहा है आपको, ये कम बड़ी बात है क्या? है ना? सो दिस इज फ्रॉम माई साइड
Yes.
ऑफ WKB अप्रोक्सीमेशन। सो आप देख रहे हो सेम चीज बार बार करना है, बार बार करना है। सो यू हैव टू जस्ट डू प्रैक्टिस एंड यू हैव टू गो द ट्यूटोरियल्स and please solve all the problem from the tutorial and then you will be in the comfortable zone. So आपको दो इंटीग्रेशन करने हैं, एक ही तरह के दोनों इंटीग्रेशन है, and you have to just practice those integration. Concept wise you have to only think that your potential is basically what? Slow varying. Means if you are moving from x to x plus dx, they are almost constant kind of thing is there. एंड ऑब्वियसली कल हमने स्लो वेरिंग की बात की भी थी कि हमारी जो रेट ऑफ चेंज ऑफ पोटेंशियल है विथ रेस्पेक्ट टू एक्स इनटू लैम्डा शुड बी लेस देन काइनेटिक एनर्जी ऑफ अ सिस्टम। सो काइनेटिक एनर्जी आपका ज्यादा होगा, पोटेंशियल का वेरिएशन कम होगा। सो दिस इज ऑल अबाउट WKB approximation and this is also identified as what? Semi classical theory. So we have finished this one. So next lot में हम लोग बात करेंगे basically perturbation. Okay, so more or less we are going to finish quantum mechanics, है ना? तो आपको रिवीजन करने की जरूरत है।